So our first session today is about serving customer data with Cosmos DB. It is going to be presented by Heber. And Heber is the data analytics manager at Grab.
Heber is going to give us a brief overview of how Grab is using Azure Cosmos DB to empower the Customer 360 API, which is an internal API that serves millions of consumer-centric data points to various systems in Grab on a daily basis to provide better user personalization. Let's welcome our first speaker of the APAC session. Heber, stage is yours.
Thank you. A very good morning, ladies and gentlemen. Welcome to this presentation. My name is Heber, a data analytics manager leading part of the analytics data product team in Grab. Today, I will be talking about how we leverage Azure Cosmos DB to serve individual customers' data to our services. Before we begin on the main topic, perhaps I can give a little introduction about Grab, who we are, and what we do. Grab is a Southeast Asian tech company, a leading super app in the region. Since its inception in 2012, it has grown rapidly, and today it offers mobility, deliveries, financial services across 8 countries in the region and over 400 cities. We also provide income opportunities for our drivers and merchant partners, and we aim to empower 1 in every 2 daily entrepreneurs in the near future. Now, as you can imagine, having this many users on the app naturally generates a lot of transactional data. And given that Grab has multiple business verticals, it is critical to consolidate these transactions into a per consumer level. This is so that we can have a holistic view of individual users' behavior. And this is where C360 project comes in. The goal of C360 project is to consolidate all our application users' data, including consumers, drivers, merchants, into individual user level in order to provide that holistic view of the user across all of Grab's business verticals. Its main product offering is internal data store, where individual consumer data points are aggregated daily using inputs from transactions and in-app behavioral data. To date, it offers thousands of data points with a coverage of over millions of users in our ecosystem. It is the single source of truth in Grab when it comes to user-level data. Having this data store provides a critical avenue for us to do all the fun analytic stuff that you usually do with customer data, such as checking in on their life cycle, doing churn prediction, segmentation for marketing, and so on. However, as the usage of the data store grows, our teams in Grab begin to look into using this data store to do personalization or real-time prediction. And this requires a very different mechanism for retrieving single rows of data from the data store on demand. All the analytical workload that was mentioned previously are what we consider offline use cases and are not really time sensitive. But to provide data points to the online use cases, we clearly need an API infrastructure that we can retrieve individual customer data on demand. So this is where the C360 API comes in. We created a series of API endpoints in order to retrieve data of consumers, drivers, and merchants using Azure API management and function app services. For the backend database, we have chosen to use Cosmos DB. Why Cosmos DB, you might ask? Why not use something like, say, MySQL? Well, there are several factors that we consider when choosing the backend technology stack. And Cosmos DB has certain features that makes it appealing as the choice of database for our use case. The first reason for choosing Cosmos DB is that it is a NoSQL database. Here, data are stored as documents, with each document representing a single row in a traditional relational database table. A group of documents are stored in containers, which is the equivalent of tables in a relational database. A single document is usually represented as a JSON object, as you see on screen, where the internal fields of the objects can be loosely structured. Whereas in a relational database, it requires well-defined schemas that are inflexible to change. The properties of a JSON object document in a document database can be easily added, updated, or removed. Why is that important to us? Well, you see, in the case of C360, although we do have many attributes, not all of them require on-demand access via API. In fact, only a handful of those attributes are actively being used. However, we do run many pilot projects, and this often need on-demand access for certain attributes for a period of time. While the pilot project is running, those attributes needs to be onboarded onto the Cosmos DB, and when the project ends, they will be removed to save costs. This creates frequent changes to the schema of the document, for which in a relational database can be difficult to handle. Meanwhile, Cosmos DB with its NoSQL format provides the flexibility that we need in order to cater for this kind of use cases. That said, being a NoSQL database is only secondary to the next reason why we choose Cosmos DB, which is its incredibly fast point read performance. Remember that our API needs to return individual consumers' data point. This is akin to like reading a single row in a relational database. Now, in a relational database, in order to achieve the optimal query performance, you need to do some kind of horizontal partitioning and probably indexing on key columns just to scratch the surface in order to quickly find the rows that you need. However, this still requires the database to engage its query engine in order to retrieve the data. Cosmos DB, on the other hand, provides the mechanism called point read. When using point read to query a document by its ID, this query bypasses the query engine of Cosmos DB and talks directly to the storage layer. This makes the retrieval of a single document blazingly fast. And here's a snapshot of the performance matrix that we have retrieved using logs from our instances. As you can see, our daily calls amount to over 50 million per day, but the average time to retrieve data from the Cosmos DB is just under 5 milliseconds. Here's a breakdown of the operation duration for requests coming in through the C360 API. Here you can see the distribution of time taken for Cosmos DB to retrieve data, and it is usually in the single-digit milliseconds, which is incredible, given that we do have a lot of data. In fact, if you look at the P95 latency, it comes just a bit around of 5.5 milliseconds. And well, speaking of a lot of data, Cosmos DB is one of the most scalable databases in the current market. As aforementioned, the C360 data store contains the data point for millions of users. Each of these users translate to a row in a relational database or a document in Cosmos DB. So as you can imagine, the volume of data we have is huge. Even with very aggressive cutting of not in use attributes in total, the data can take up to more than a TB. Given that these data points are refreshed daily, writing in the new data into the Cosmos DB is a task that demands large amount of computational power. And this increase in computation power is on top of the normal capacity which we provisioned in order to serve the existing data. However, because this spike in demand of computational power is transitionary, the database needs to provide temporary additional resources only for ingestion. In a normal DB or DB cluster, the operation to increase this throughput may take up to several hours. However, for Cosmos DB, thanks to its auto-scaling containers, this operation can be done in less than 10 minutes or so. So now, having showcased some of Cosmos DB's strengths, it is not without some downsides. The biggest one being that Cosmos DB does not have segregation between its read and write traffic provisions. Now, both read and write traffic of the Cosmos DB shares the same amount throughput that is being provisioned. So when one side of the traffic gets high, it will eat into the bandwidth of the other, where the other can operate it. This caused us quite a bit of trouble initially, since our daily updates writes a large amount of data into the container, and that blocks the read traffic from the Cosmos DB. Since our services run online 24/7, it creates an issue where the dependent services on our API cannot reliably retrieve data from the API during those daily data ingestion periods. To resolve this issue, we actually implemented a rotating container strategy. Each day, the updated data is loaded in the new container, while the existing containers continues to serve read requests. Once the data loading is complete, we switch the API to read from the new container. The old container is then deleted. This rotating container strategy ensures that data retrieval will not be disrupted by the high traffic of data loading. So leveraging on all these strengths of Cosmos DB, we have created the C360 API as a serving platform for our user level attributes. Currently, there are several production use cases that are accessing these attributes via the API. And I'm going to showcase two of them here. One of such use case is to feed user level attributes to our data science models for fraudulent transaction detection. Here, data points are retrieved by our data science model using a transaction whenever a transaction occurs on the application, and it will classify if the transaction is possibly fraudulent. We do have a very high daily transaction numbers, and as such, having a low latency API for this user level attribute retrieval is critical, since we do need additional buffer time for the predictive models to run. And overall, we want to compress that response time of between the user making a transaction to retrieving data from the data store and having the prediction model run to under 500 milliseconds. Here is where the speed of Cosmos DB point rate really comes into play, as we are able to serve large amount of requests that are coming in at an average latency of around 50 milliseconds round trip. This creates that buffer time for our predictive model to run, and it allows for a more complex model to run, which takes up more time, which usually ranges to around a few hundred milliseconds or so. And that is critical for providing the kind of smooth user experience that we want for our app. Another use case is to provide differentiated customer service for different user segments. Here, user segments are predetermined by an offline data science model, and the results are loaded into the C360 data store as an attribute. This attribute is then loaded onto the Cosmos DB API for serving. Whenever a user contacts our customer service agents, our agents will first check through the customer service terminal, which will query our API in order to retrieve the user's segment. This user segment will indicate the user's classification, and we use that to identify high-value customers for priority services. So in conclusion, Cosmos DB has been fulfilling the needs of serving individual user level data retrieval exceptionally. Its no SQL format, fast point read performance, and rapidly scaling capacities has allowed us to create a system to serve such data reliably and efficiently. In our future roadmap, we plan to expand on the capacity of C360 API by optimizing the other parts of the system, such as the function app API endpoint code, and also the network configuration connecting the API management and the function app instances in order to reduce latency further. Additionally, we do hope to look into optimizing the daily data loading jobs. And we do that by optimizing the data pipelines that are currently running on Databricks. I hope this talk has given you some insights as to how Cosmos DB has been useful in serving customer level data. Thank you for coming to this talk. And before we end the session, perhaps we can take some questions from the audience.
Thanks so much, Heber. That was really great. We do not have any questions right now. Yeah, go ahead, Saji.
I noticed that you have built it using Azure Functions, API Management, and Cosmos DB, and you mentioned you're handling millions of requests across 20 instances, so with some of the container rotating strategies. So what are the best DevOps practices that you follow in terms of monitoring and troubleshooting?
In terms of monitoring and troubleshooting, I think the best DevOps we do use, so essentially our entire development ecosystem lives on Azure. On the DevOps side of things, we leverage on the Azure DevOps instances, which provides the feature called pipelines in order to deploy code reliably onto the function app themselves. And it provides the standard suite of CI/CD features that you will find on the other GitLab or GitHub websites. So that is very easily transferable. And so for data pipeline wise, we also do CI/CD for the data pipelines. We have a staging instance of the data pipelines, a staging Cosmos DB container, where we test out whether the data pipeline works when it comes to data ingestion. And the staging Cosmos DB instance do connect to a staging instance of the API endpoints, where users can test out and access the full range of attributes that we have. It is only when the users have tested out their use case on our staging APIs, that's when they can submit a request to us to say like, hey, we would like to access this attribute that you have on the production API endpoint. And that is when on the back end, we switch that attribute on the production API endpoint. And on the next day, that attribute will be uploaded to the production Cosmos DB data store. So having this very clear segregation ensures that our end users have some place to test out whatever they are using before they actually goes into use it in the production environment.
Got it. Thanks for sharing that insight. Yeah.
And I assume these are, like you said, and I know that Grab also operates across multiple industries. So your consumers are essentially these other teams within Grab, who I assume are from retail, transportation, different teams. Is that right?
Yeah, that's right. Our consumers are all the internal teams that are developing product features on the app.
Awesome. So do you have to, we provide like 5 nines of SLA in Cosmos DB, and how do you provide an internal SLA, commit to an internal SLA for your users? How does that work, and how are you able to achieve that?
Oh, well, in terms of internal SLA, we mark it by the round trip latency on Azure, and also the error rate. For round trip latency, we promise that it will be lesser than 150 milliseconds. And in terms of error rate, it will be 4 nines, 99.99% uptime. So far, we were able to do so using a pretty lean team. It's also partly thanks to the stability of Cosmos DB itself. We have not encountered any major issues whereby there's an outrage on the containers or the service. And overall, the experience has been pretty smooth in terms of using the service.
Awesome. Do you use single region, multiple regions?
Uh, yeah, we only use a single region on the Southeast Asian region,
Hmm.
and that is basically where all our businesses are concentrated on. So having that uh, instance on in the region itself is also part of the reason why we were able to achieve this kind of low latency performance.
Right. Yeah. Makes sense. And yeah, approximately, I would say, how many requests per second does your workload operate at? And I mean, what's the scale of traffic that you're able to achieve with your databases?
Uh, well, at the highest point, it can handle a couple thousand. It has handled a couple thousand requests per second, and
Hmm.
we are not seeing any strains on the database so far. So we believe that there's still room for it to handle more requests per second. We do hope to achieve an eventual point whereby it can handle 20,000 requests per second. But that is barring that we resolve some bottlenecks on the networking between the different cloud components themselves. So this is currently one of our projects in uh, progress. Perhaps next year when we have a different we have the next Cosmo DB Conf, we will be able to share with you how we actually optimize the performance of this API.
I have one more last question before we
Mm.
wind up. Like you mentioned that you are using Cosmos DB heavily, like, and you mentioned some of the use cases. Since Cosmos DB is a multimodal database, what are the APIs that you currently use?
Sorry, I didn't quite get the question. Could you repeat it again?
Are you using only the SQL API, Mongo API, or
We are only using the SQL API.
okay, got it,
Yeah,
got it.
the use case is pretty straightforward, and so SQL API was sufficient for whatever that we need.
Okay, yeah, I think that's all we had on the question side.
Well, thank you very much for giving me this time to do my presentation. I hope you have enjoyed it. And yeah, I think that
Thanks.
will be all from my side.
Thanks so much, Heber. That was awesome.